Hi, hello everybody. Welcome back to Anode Academy. This is me, Ankita, and today we'll be doing certain problems from finding the electronic configuration and also to determine the period, group, and block of certain configurations which are given to you. Okay. So in the previous session, we already discussed about the different principles like the off-book principle, the Pauli's exclusion principle, Hund's rule of maximum multiplicity, etc. Okay, so today we are going to address the periodic table in detail. Okay, so if you can see, the periodic table has got seven. Okay, please note it down. So this is actually taken from the Google. Okay. So we have seven periods in total. Periods in the sense like these. 1, 2, 3, 4, 5, 6, 7. Okay. So we have seven periods or rows, you can say, whichever is comfortable to you. And if you check the columns, there are 18 columns and they are actually called groups. Okay, groups. So 7 periods and 18 groups are what is present. Now if you're not familiar, you might feel that this is an 8th one, 9th one. No, this is actually placed over here. This one actually belongs to the 6th period and this one belongs to the 7th period. Okay. These are called the lanthanides and the actinides. We'll be discussing about them in detail. So if you can see that each period has got a certain number of elements and they are again divided into certain blocks. So the first two, these are called the S block elements. Then from this element to this element, these are the D block elements. You have to include zinc as well, this one, sorry. So if you can see certain numbers, third group to 12th group is actually D block elements. And from 13th group to 18th group, they belong to P block element. And these two, which is kept at the bottom, belongs to F block elements. Now, why is it called S, P, D, and F? We'll be learning that. Okay. Now, if a question is there, like you have to write the electronic configuration corresponding to 27, let's say. Z is equal to 27. This is our question. So already we know a way by which we can write it, which we have already discussed in the previous session. I'm not redrawing it. I'm copy pasting the same stuff which we learned in the previous session, on the basis of which we already know the order in which you have to fill the electrons. If it is not a single electron species, right? How do we fill it? So the first one is 1s, 1s2. So the atomic number is represented by Z and that is equal to 27. Okay. So 1s2. Next comes 2s, 2s2. So you can see, right? 1s2, 2s2, and next comes 2p and 3s. Okay. So let's see. 2p and 3s. So in P, we know by now that there are 3 orbitals. Each of these can accommodate 2 electrons each and a total of 6 electrons. Then comes 3s2. You know now, S can have a maximum of 2 electrons. P can have 6 electrons. D can have a maximum of 10 electrons. F can have a maximum of 14 electrons. We have learned about shells, subshells, orbitals, etc. Okay, quickly revise. So 3s2 is done. Then who is next? So see, next one is 3p, 4s. Okay. So next comes 3p6, 4s2. Let's count the number of electrons. 2 plus 2, 4, plus 6, 10, plus 2, 12, plus 6, 18, plus 2, 20. So now it is 20 and our number is 27. 7 more electrons. Let's see who is next. After 4s, it is 3d. Correct. So 3d, we know d can accommodate 10 electrons, but we need only 7. So 3d7 and this is the answer. Okay. Now this is easy because the atomic number which was given was small. So you can draw this and you can start writing all this. But let's say you're given a very big atomic number like Z is equal to 80. What will you do? Okay, it will take a lot of time to draw this and then write it. Okay, it will take a lot of time. So what are we going to do? We are going to tabulate it and you have to learn. You have to learn it so that you can quickly write the electronic configuration of any element which is given to you. So I'll explain how that is done. Okay. So first one is you write period. We know now how many periods are there. Now we know that there are 7 periods and that is equal to the number of shell as well. This is the first column. Okay. Next one is increasing energy of orbitals. Third one is number of elements. And fourth one is noble gas. Who is called the noble gas? The last group. The group which is present at the end, which is the 18th group. We said, no, we have 18 columns. So the one which is present at the rightmost end, this one. This is the noble gas. Okay, so let's try to understand. Look at the periodic table, please. So this is our first period, hydrogen, helium. This is our first period wherein electrons enter into the first shell. Okay, let me explain the second period also. This is the second period wherein the elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. How many elements are there? 8 of them. 8 of them are there. And as it belongs to the second period, the electrons enter into the second shell. Okay. Similarly, any period they are to take. If you take any of the, let's say, this is the fifth one, right? So here, the electrons will enter into the fifth shell for sure. This is the seventh period. The electrons will enter into the seventh shell for sure. Okay. So the first column is the first period. The first period has got only 2 elements, as we could see, hydrogen and helium. Out of which helium is the noble gas, helium, whose atomic number is 2. That is what I'm writing at the bottom. Okay. Noble gas, atomic number 2. Now, what are the orbitals which are present over here? So we said that here we'll be having only one shell, which corresponds to 1. And we know that it is only 1s. We do not have 1p, we do not have 1d. So it's just 1s. 1s can have 2 electrons and hence the number of elements is equal to 2. Okay. Next one. Second shell, which are the orbitals? So we know that 2s and 2p. Correct. This is increasing order also. 2s is less energetic than 2p. We have learned about the n plus L rule. So we know that s can take 2 electrons, p can take 6 electrons. So there are a total of 8 electrons and hence the number of elements that are present is 8. Okay, now in the second period, see already 2 electrons, you have to be careful, okay? Let me explain. So see, this is 1, this is 2. Then atomic number 3 comes over here, right? 4, 5, 6, 7, 8, 9, 10. So the noble gas, which is present in the second period, has an atomic number of 10. How did you get that? How can you calculate it? So neon is 10. How do you get that? It is this 2 plus this 8. Helium was the noble gas in the first period and then you have 8 elements resulting in neon. Correct? Now, next, let's see. 3. Who all are present? We know 3s and 3p only. You might think 3d is also present, but no. Why? Because, let me go back. If you look at 3d, you can see that 4s is filled before 3d. So if the electron enters 4s means it belongs to the fourth period and not the third period. Okay, I repeat, you might feel that if it is a third shell, the orbitals would be 3s, 3p and 3d. No. That's wrong. Why? Because the energy of 4s, as we know from n plus L rule, is lower than 3d. Here the n plus L, 4 plus 0 is 4. And here n plus L, 3 plus 2 is 5. So if an electron enters the fourth orbital, which is 4s, then it belongs to the fourth shell and not the third shell. Okay. So we have only 3s and 3p again, which again gives 2 plus 6, 8 electrons, meaning 8 elements. Okay. So you have some element over here whose atomic number, can you tell me? We stopped at the end of second period, which was 10, followed by 8 elements. Meaning the atomic number over here will be 18, and the name you have to learn is argon. Argon. Next, 4s. Be careful, do not write. Let me say. See, it is 4s, 3d, 4p. How did we get this energy from this diagram? See, 4s, 3d, 4p, and then comes 5s. So now this goes to the fifth period. This is the starting of the fifth period. So in the fourth period, you have elements where the electrons enter 4p, 3d, and 4p. Okay? 4s, 3d, 4p. So 2 plus 10, 12, plus 6, 18. So now 18 of them are there. So the next noble gas configuration would be 18 plus 18, which is 36, and that corresponds to krypton. Fine. Look from this table and please write. So we are at 4p. After 4p comes 5s, 4d, 5p. That's it. Next it is 6s. So that goes to the sixth period. Okay, I hope you are understanding. So this is 5s, 4d, and 5p. So how many electrons? Again, 2 plus 10, 12 plus 6, 18. So now you have 36 plus 18, which is 54, would be the noble gas corresponding to the end of the fifth period, and that corresponds to xenon. That corresponds to xenon. Next is sixth period. Look, 6s, correct? And next comes 4f, 5d, and 6p. So let's write it down. 6s, and then is 6s, 4f, 5d, and who is it? 6p. So how many? 2 plus 14 plus 10 plus 6. 32. So 54 plus 32 is 86. And that corresponds to radon, Rn. Last one, seventh one, it would be 7s, and then 5f, 6d, and 7p. Again, 32 elements, and that is 118. So it's good if you can learn this. 118. Organosine. Organosine is the element. This is radon. Okay. So using this table, you can easily write the electronic configuration of any element which is given to you. Let's say that the element which is given to you is 60. Okay, we'll start with an easier one. Let's say that the element which is given to you is 6 and all is very easy, no? Let's say it is 31. Let's say it is 31. Example, Z is equal to 31. So from here, you already know that up to 18, you get the configuration of argon. So you can write it like that. And argon, you have to learn is belongs to what period? It belongs to the third period. So next you have to start from 4s because you're entering into the fourth shell. And after 4s comes 3d and 4p. These are the possibilities. Now your number is 31. So let's add 18, 2 electrons over here. Now it is 20. Plus 10, 30. 1, 31. This is how you can write the configuration. Let's say your configuration Z value is 80. So if it is 80, you have to know that this is the noble gas of 1, 2, 3, 4, 5. 54 comes before 80 and that corresponds to the noble gas which is present at the end of fifth period. So xenon is present at the end of fifth period. So the next one will start with 6s. Correct? Now you have entered the sixth period and you know you will be having lanthanines and actinines, which are the F block elements. Or from here, you know the energy level series. Learn the table. 6s, 4s, 5d, and 6p is the energy order. Okay, so now you're at 54 plus 2, 56. And then 14 electrons can be there. So 56 plus 4, 60 plus 10, 70. And then you add again 10, 80. That's it. This is the electronic configuration corresponding to Z is equal to 80. Okay, it's easy. Let's say you have 45. Z is equal to 45. So the moment you hear 45, it should come to your mind that there is a noble gas which ends at 36 and who is krypton. And that belongs to the fourth period. This much should come to your mind. So you should learn these: helium 2, neon 10, argon 18, krypton 36, xenon 54, radon 86, organosin 118. Okay, this can be actually drawn if you want. This thing can be drawn at the moment, or you can find it by n plus L, anything. Okay, so now you are at krypton and you know that this is at the end of fourth period. Now you need how many more? 9 more. And we know that next one would be 5s and then 4d, 5p. Correct? So this is 238 plus 10 became 48. We don't need that much. 38 plus 7. That's it. So this is how you write the electronic configuration. You will get options like these at times. So you should know what it means. Okay. Now, the main purpose is to find the group, period, and block of an element. So let's write it one by one. Determination of group, period, and block. Let's say you get a question like this. So some configuration is given to you and you have to write to which group does it belong, to which period does it belong, and which block. Okay, period is very easy. Period is the highest value of principal quantum number. Highest value of principal quantum number n. Okay, so in the configuration, whichever number is the highest, that would be the period to which it belongs, which we have already learned. Now, block, as I said, there are S block, P block, D, and F. And that depends on the electron where it enters. For example, here the final electron enters into the p subshell and hence this belongs to the p block. Here it enters to the d and hence this is d block. If it stops at S, it will be S block, and if it ends in F, it would be an F block. Okay, so how do you find it is the next question. So the way you find it is block. If it is S block, okay, very easy. Last electron enters to the S subshell. P block also the story is the same. Last electron enters to the P subshell. Here, if it is D block, last electron enters to N-1 D shell. You will get to understand when we solve problems. And if it is F block, the last electron enters to N-2 shell, subshell. Which means, let's say, again, let's go to our example. And here, if we can see, this belongs to 6th period because the highest number over here is 6, 6th period. Okay, so the value of n is equal to 6. And if you look at the last electron, it is entering into the D subshell and hence this belongs to the D block element. And can you see the value which is associated with D? It is N-1D, 5D. Okay. Did you get it? So that is, if it enters into the F shell, it would be always N-2, which is there at the end. Okay, let's do an example. Write the electronic configuration of 67. Okay. So we know that the noble gas, which is ahead, is 54. Then you have 6s2, which is 56. You need 11 more, which I'm going to add to the 4f. So this, here the last electron is entering into the F subshell, but which F subshell? See, the highest value over here is 6. So n is equal to 6. But the last electron is entering into a shell whose value is n-2f. So that is the difference. So if you have a d orbital, it always enters into the penultimate shell. N-1 is said as penultimate. One shell ahead. If it is 6 means the D subshell will be associated with 5. And in the case of F, it is anti-penultimate. Anti-penultimate. These are very basic things. So this is how you determine the block. Now the next one is to determine the group. If you have to determine the group, if it is for S, or if it enters into the S electrons, S subshell, it is just number of electrons in S subshell if it belongs to the S block. S block. If our element belongs to P block, then it is 12 plus number of electrons in P shell. P subshell, sorry. You have to add 12. Why 12? Because see, the P block comes after 12 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry. Yeah. So from left, it is 12 groups ahead. This is where our P block stands from. So you have to take into account the 12 rows, sorry, the 12 columns ahead of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. These must be considered. Next, if it belongs to D block. If it belongs to D block, all you have to do is number of electrons in S plus D subshell. That's all. And if it belongs to F block, very easy, always belongs to third group. Always in third group. We said, right, these elements, see, these elements, where is it? Yeah. This is group 3. And this is where lanthanides are placed. These 7. And the below one, in the 7th period, you have actinides, the next 7. Okay. So those F block elements are in group 3. Okay. So let's try and solve from problems, from whatever is there on the screen. Just go through whatever we have written and let's try them out. So, question, you write the electronic configuration and you tell me to which block, period, and group it belongs to. Let's say Z is equal to 37. Z is equal to 37. Okay. So we know the noble gas, which is ahead or which is before 37 is 36, and that is krypton. Krypton comes at the end of 4th period. So the next one will enter 5s, correct? We have only one electron, so it is krypton 36 5s1. This is the electronic configuration. So by just looking at this, the last electron has entered into the S subshell and hence this belongs to S block. The highest value of the principal quantum number over here is 5 and hence n is equal to 5 and this is the period, 5th period. And to which group does it belong? If it is S, it is just the number of electrons in the S subshell. So 1. That is the group number. Easy. Okay, next 42. 42. So again, I know the noble gas which is before 42 is 36. I need 6 more. So after 5s, I have 4d. 2 electrons will enter S, 38. Then the rest 4 will enter into, 30. Yeah. The rest 4 will enter into 4d. So now, see. Since the last electron has entered into the D subshell, this belongs to D block. And over here you have 5 and 4. The highest value will correspond to the period. So n is equal to 5 again. 5th period. And the group, the way you find is, if it is the D block element, you have to add the number of electrons in S and D. 2 plus 4, 6. So it is group 6. If you want to cross check, you can cross check. 42 is molybdenum. See, 42 is molybdenum. Group 6, period 5, and it is in the D block element. Okay. All right. Let's try another question. Atomic number 84. 84. Write the electronic configuration. 86 is radon. So this is 84. So the one which is ahead is xenon 54. Xenon 54. See, after which you have 6s, 4f, 5d, and 6p. 6s, 4f, 5d, and 6p. 84, no? So 2, 14, 10, 54, 64, 74, 84. This is how it is. This is the configuration. Last electron has entered the p subshell and hence it belongs to p block. Period. The largest number of quantum number over here is 6. So, 6th period. And group, if it is P, what you have to do is you have to add 12 to the number of electrons which are present. So, 12 plus 4, 16. Group 16. Okay. So, this is the way you will do. Easy, na? Okay, try 63. Last, 63. 63. Again, we know that the noble gas before is xenon, 54. Then you have 6s2, so 56. You need 7 more, which can be accommodated in 4f. Correct? Yes. So this is 63. So which block does it belong to? Last electron is entering into the F subshell. So this is F block. And the largest value of quantum number here is 6. So n is equal to 6. And that is the period. And if you want the block, F block we got. Now the group is left. Always F block elements belong to group 3. Okay. All right. So that's it. That's the end of the session. So practice, practice, practice. Learn this. Okay. So all you need to know is this table. You can write any electronic configuration, provided the energy, the order of the energy in which you write this is correct. All right. So that's all for today. See you in the next.